So we have seen kind of a overview about data lifecycle management, and then got some idea about basic data ingestion, and went little detailed about the nature of sources and types of data sources. And before getting into the hands-on of ingestion, uh, gaining the knowledge about the modern platform, data platform, is something good to have, and I can even say it's a must to have, right? So this is a kind of a simplified view of the modern data platform. So we start with the streaming data. You know what is the streaming data? Continuous data which is coming from the source. So here I have listed few like the machine data, the telecom data, and app data, and then the batch data. Batch data is nothing but it runs on a scheduled frequency. So I have kept some PDF files, a data warehouse, flat files, and transactional database. Now between these two, you can easily identify what could be your structured data source, what could be your unstructured data source, what could be your semi-structured data source. So just give a try. Yes, uh, the database and data marts would be your structured data source. The PDFs and flat files would be of your unstructured data source, and the data from your machine and your application might be falls under the category of semi-structured. It might send XML or JSON file as logs. So then comes the data ingestion layer, where you will be loading the data to corresponding layers. So the stream data goes into stream processing, stream analytics services, and a storage, and the batch data gets into a data lake, where you have a data lake storage, data processing. Normally the data comes to, initially it gets into a landing zone, which in some cases they call it a landing zone, some cases they call it a staging layer, which is a transient layer. It is a short-lived space for the data, and once the data moves to raw, that particular data will be deleted on the next run subsequently from the stage. And raw is like more of whatever that is available in the source will be copied as is, and it goes to the clean layer. So this is entire process. This entire processing will happen inside the data lake. So from source to raw, it will be source to stage. It will be one to one. Stage to raw will be on append mode, and raw to clean is more of the data quality checks, data consistency checks. Everything will happen in that. So everything will build as a data pipeline. So the source to clean will be a pipeline. So it depends on which cloud you are using or which platform you are adapting. You can use the open source tools, cloud agnostic tools, Python, Scala, Spark, or you can use any Informatica or any ETL tools that is available in the market, or you can use cloud native tools like ADFs, Glue, etc. We will see one by one in the upcoming episodes. Once the data gets into the clean layer, then the next subsequent consumption will start. So it will have an integration layer. So here we have a data warehouse in this architecture. So data warehouse will deal only with your structured data. So this operational data from the clean layer will be used in the data warehouse, which will be then transformed into a modeled data or conformed data. And similarly, the data from the clean layer will be provisioned for the data science platform, where the scientists will also consume data from the data warehouse, where they will prepare the models and train the models and prepare some ML outputs out of it. So all these platforms will be given for access for further analytics. Let's say the stream data will be provisioned for real-time analytics, and through which we can generate some quick win dashboards and reports for immediate actions. And then the enterprise analytics, where we will prepare more of a decision making dashboards and ML dashboards. So all this will be consumed by data analysts, business users, and data scientists. So this is very simplified form of a data architecture, where we have a governance layer which covers the entire life cycle, right from your ingestion till your consumption. Governance is nothing but, governing the data, the policies, the access, the roles, uh, and ensuring the quality of the data. All this will come under governance. And orchestration is nothing but running the jobs, the pipelines, which should start first, which should trigger next, all those orchestration and planning. And DevOps is nothing but your continuous CI/CD, continuous integration and continuous deployment framework. This will spread across all the layers. So this is a very overly simplified architecture just for an understanding purpose. According to the solution, if you are adopting an on-premise, the structure might get changed. According to use case, it might change. If you are adopting a cloud, the technologies and the architecture might get changed. It's like, constructing a house. According to your given landscape and given requirements, you may opt for a design, right? Very similar to that. This is a reference structure. Typically, these are all the layers that will involve in the entire architecture. Some are must to have, some are nice to have. So this is how the architecture will look like. So just gain this understanding, and possibly in the ingestion part of it, right, we will take a very simple use case for the hands-on exercise. So this is what I have decided. Like, we'll use an Azure platform for this exercise, where we will use a couple of data sets, publicly available data sets in the form of CSV and JSON, and we will use Azure Data Factory and Storage Explorer to do the ingestion to Gen2, data like Gen2. So I'll do all these operations in a hands-on mode. So I hope this gives a fair understanding on the architecture. Do let me know if you have any questions. This is a very critical thing you need to know. You cannot straight away jump into a coding, right? So you need to have what you are doing in that entire plan of architecture, which part you are doing. So we will start with ingestion in the next episode, a purely hands-on episode. For now, just go through this one more time and shoot your questions if you have anything. See you in the next episode.